The topic is ground-based sensor and remote sensing presented by Anuja APCSC. Ground-based sensor. Precision agriculture provides the tools and technologies to identify in-field soil and crop variability, offering a means to improve subfield level farming practices and optimizing organic inputs. Variable rate technology provides the capability to vary the rate of soil and crop applied inputs for site-specific applications. Today, sensing technologies, both ground-based and remote, continue to evolve and have become cheaper for capturing field-level data. For the operational success of VRT, that is variable rate technology, maps of crop growth, crop diseases, weeds, crop nutrient deficiencies, and other crop and soil conditions are required. As a result, map depicting crop and soil variability through remote sense image acquired by sensor mounted on satellites. Aircraft or ground-based equipment have become an integral part of VRT. So this is a sample diagram for sensor-based data. Then remote sensing, the sense of acquiring information about an object without entering in contact with it by sensing and recording reflected or emitted energy and processing, analyzing and applying that information. So this is a sample diagram for remote sensing. The remote sensing is the process of acquiring information about the Earth's surface by measuring its reflected and emitted radiation without coming into direct contact with the object. In much of remote sensing, the process involves an interaction between incident radiation and the target of interest. The most useful electromagnetic radiation in remote sensing include visible light, near-infrared, short-wave infrared to thermal infrared and microwave band. So this is the sample diagram for a depiction of process involves the remote sensing. The different objects based on their structural, chemical and physical properties reflect or emit different amount of energy in different wavelength ranges of the EMS. So the sensor measures that amount of energy reflected from that object. So this is the sample graph or wavelength of sensor. The essential component of remote sensing, signal from a source or light, sensor on a platform, then sensing or signal reception, storage, processing, information extraction and decision making. The remote sensing process, so reflection of data, air photos and digital data, it can move on to the visual and digitals. So then it can be move on to map, statistics and GIS data set and user decision making. So it can be categorized as 4 parts, that is data product, interpretations and information product and target audience. Types of remote sensing: passive remote sensing, another one is active remote sensing. Passive remote sensing, sensing sensor record incident radiations reflected or emitted from the object, while active sensor emit their own radiation, which interact with the target to be investigated and returns to the measuring instrument. So this is the sample diagram for remote sensing using passive sensor as well as the active sensor. Applications of remote sensor in agriculture: identifications, area estimation and monitoring, crop nutrient deficiency detection, soil mapping, crop condition assessment, agriculture drought assessment and reflectance modeling, crop yield modeling and production forecasting. Thank you.